I just got done making this solid copper ice press that turns pieces of ice like this into perfect spheres. It works amazingly well. This thing's a perfect sphere. So cool. I just wish we could see what was going on in here. So in today's video, I'm gonna remake this piece, and instead of having copper around this area, I'm gonna replace that with clear acrylic. That way, we should be able to see exactly what's going on all the way up until the point where it becomes a perfect sphere. And that should be incredibly cool when it comes time to put dry ice in here. That's crazy. Whoa. I did that in my last video and the reaction was really spectacular. So it'll be really cool to actually see what's going on in there. In my last video, I showed you how I used lost PLA to make these pretty complicated parts. And I'll be using that same technique to make this part. This great big piece here is called a riser. It'll just supply the main casting with metal as it solidifies and shrinks. And it has to be really big like that so that it's the last part to solidify. I'll also be able to put it in the lathe like this and machine down this section so that this piece of acrylic slides over. And then I can switch it around and machine this down and turn that into a handle. So here's the shell after I burned out all that plastic and turned this thing into ceramic in the kiln. It looks really nice, there's no problems at all, it didn't crack or anything like that, so that's really good. Now I'm gonna stick it back into the kiln, turn it up to about 1500 degrees Fahrenheit, and then pour in the molten copper. Right now I'm in the process of weighing out all the copper that I'm going to need for this project. The CAD software that I use tells me that I need 5,500 grams for this casting. This is one of the pieces that I'm going to melt, and it's the sprue from this piece here. Big pieces of metal like this take a long time to melt, so I cut it in half, and when I did that I revealed these large pits in it. That could be a problem because the sprue on the casting that I'm making now is a very similar size to this, and if it's full of holes, then I'm not going to be able to use it as a handle, and that was my plan. So I hope I don't have to machine a new handle because that's going to be a lot of work. When you load these crucibles, you have to be really careful because if you wedge pieces in here, they'll expand as they're melting and they'll actually crack the crucible. There we go, that'll work. Right before I do the casting, I'm gonna add just a little bit of this phosphor copper to the metal, and that'll degas it and make sure that the casting doesn't come out really porous. Here it is after I broke off the shell and cleaned it up a little bit with the sandblaster. All of the important parts look really good, but unfortunately there is some shrinkage around this area. I'm not really sure why that happens, but it shouldn't be an issue because I am going to be machining most of this away anyways. My original plan was to make a handle out of this piece, but the more I think about it, the more I realize that the odds of it being solid are really slim. So instead, I'm just gonna cut this piece off and I'll make a handle out of this piece of copper bar stock. Well, I was definitely right to be worried about it because this looks awful. Not exactly sure what I'm gonna do about that. My original plan to attach the handle was to drill and tap a hole here, but obviously I couldn't do that, so instead I just bored it out and now I can just press the handle in without the need for threads. That worked really well, and now this handle's definitely locked in place. It's not going anywhere, so I'm really happy about that. I thought it was done at this point, but I remembered that I actually wanted to drill a hole going from the top of the handle into this cavity here, and that's gonna help with drainage. Obviously the time to have done that was when this thing was chucked up in the lathe, but now that it's out of the lathe, I'm just gonna use my milling machine. And the reason I'm gonna use the milling machine instead of the lathe is because I don't wanna put it back in the lathe and further damage this really soft copper. You can see that it does leave some indentations there, and I wanna avoid that as much as possible. Fortunately, I do have some of these stub flute drill bits, which are a lot more rigid than a normal drill bit, and because I have to go through quite a bit of copper, the rigidity of this drill bit will hopefully prevent it from kind of wandering off, and I should end up with a really straight hole. It might still wander a little bit, but I think this will give me the best chance possible. Did I say I was gonna drill a hole? Well, what I meant was I'm gonna drill a hole and then break a drill bit off inside of it, getting it completely and hopelessly stuck. No idea what I'm gonna do now. Good thing I was using that fancy drill bit, huh? I think I came up with a solution. What I'm gonna do is just flip it around like this, and then I'll drill down from this side, and when I feel the drill bit, I can use a punch and just kind of knock it out of there. Hopefully that works. All right, I can feel it with a drill bit, so let's see if I can knock it out with a punch. Oh yeah, it's moving. There it is. Well, I finally got that stuck drill bit out of here, which is a big relief. Now all I have to do is clean it up and then try it out. Well, there's nothing left to do but to try this thing out, so let's see how well it works. Got a nice piece of clear ice here. Really curious to see how well this hole is gonna work. All right, here it goes. That really is cool that you can see what's going on in here. I know it's just melting ice, but it's nice to see. Oh yeah, there's water coming up out of here. Did you see that? There's definitely a lot of water coming out of there. More than I expected, actually. There we go. That was quick. Maybe 30 seconds. That never gets old. I know some of you were pretty upset that I had Diet Coke last time, so I actually have a real drink this time. And something you don't really get in the video is just how heavy these things are. So this piece here weighs the same as a gallon of water, about 8 pounds. There it goes. That's cool. There it is. Again, I think that was about 30 seconds. There we go. So satisfying. I'll just put this in here and save it for later. I think it's time to go get some dry ice. Actually, before I get the dry ice, I'm kind of curious to see how big of a difference this hole makes in terms of how fast it melts the ice. So what I'm going to do is I have 2 pieces of ice that are as close as I could reasonably get them. I'll melt one and then I'll warm this thing back up to the ambient temperature of the garage, and then I'll melt the other one with the hole plugged, and we'll see if it makes any difference at all. Of course, this was just one test, but it does seem like the hole actually helped melt the ice a little bit faster. Let's try some dry ice. Well, that was over a week ago. I just couldn't find dry ice anywhere. It was just sold out everywhere I looked, but I finally tracked some down, so now we can test it out. I don't even know if you can cut dry ice like this. Well, this is not working at all. That didn't work. There we go. If you fell asleep to this video, this would be a good time to wake up. Just suddenly stops. That's awesome. Yeah, kind of similar to last time. I read through the comments, and there are a couple suggestions that I'm going to try out. So next, what I'm going to do is try to put a little bit of water in here and see if that changes anything. I'll add a little bit in here and then a little bit right there, and we'll see if that does anything. There's air coming up out of here, or CO2, I guess. Not very much, but it's coming up. Worked. Wow, look at that. Oh, from my perspective, it looked a lot more spherical. Yeah. I think what I'll try next is heating it up and then putting the dry ice in there, and we'll see if that makes any difference. They're about 120 Fahrenheit now. That's as hot as my tap water gets, but I think I can do a little better than that. Not a big difference initially. We'll see. I can't say there was a huge difference with this being hot. I think it was just as fast as when this thing was the temperature of the garage, which is about 80 degrees. Watch how long this thing spins in here. Once it settles down, it'll just be quiet. See? Totally quiet, because I don't think it's actually contacting the copper at all. It's sublimating and turning into CO2 gas, and there's a barrier of gas between the dry ice and the copper, so it's basically like it's not even contacting it. There's almost no friction, so this thing is just spinning and spinning and spinning. I believe this is called the Leidenfrost effect, and correct me if I'm wrong. Well, that was a lot of fun, but I want to try one last thing. I wonder if you can use dry ice in a drink. Let's find out. This seems like a great idea. It looks awesome, I have to say. I don't even know if I can drink this. Seems like a terrible idea. Yeah, I changed my mind. I'm definitely not doing this. This thing is breaking off little pieces and I don't want that to get down into my stomach, so I'm just gonna have to wait for this to melt. I hope you guys enjoyed watching me make this thing. I thought this ice press deserved another video, and originally I thought this whole clear shroud project was only gonna take me a week or two, but like everything else that I do, it took way longer, and now it's 3 months later. But anyways, I hope you guys enjoyed the video, and I'll see you in the next one. Thanks for watching.